The next challenge is, what if we have different periods of time for two projects? In the LNS, we had the exact same time period, but look at this one. We have T and F. T is a 2-year and F is a 4-year, and we have this cash flow. -100 outlay for both, but the lifespan of the first one is 2 years and you get $60 a year. The lifespan of the second one is 4 years and you get $33.5. Let's start with basics and let's do an NPV in this case. Here when this next tab, if we do the NPV, let's do it for project T, equals NPV, open parens, discount rate is 10%, comma, and go out to T1 and 2. Outlay is $100, and NPV is that plus that, or $4. All right, so let's go out to F, and F is equals NPV, open parens, 10%, comma, years 1 through 4, close parens. We have an outlay of $100, so we make $6. So here we would say, well, I'd rather have $6 than 4, so that's a no-brainer. We will do this one, right, versus this one. But there's a problem. The problem here is that we have one that's 2 years and one that's 4. So we're kind of comparing apples to oranges. So how do we address this issue before we make a decision and recommend the second project, the 4-year project? So one approach is to look at making it equal in terms of annual annuity. So this is the idea where we know there's lumpy cash flow and different irregular cash flow. But let's assume that each project generates a set amount of monthly every year, which is what an annuity is. It's a payment inside of a present value, future value calculation. Here, the steps seem a little bit illogical, so stay with me. So the first thing you do is you determine the NPV of the uneven cash flows. Then you use that number as the PV, and then you specify the last year as T with a 0 future value, and then you force the computation of what payment draws down that present value back down to 0. And that's what we're doing. So I'll show you that in Excel. That might make more sense. But I must admit this one most students have a harder time visualizing. So let's just do the calculation. That may help. So the NPV we already determined was $4. And the EAA is, okay, if I want to figure out the payment, PMT, open parens, the rate is 10%. That's right there, comma, what is the number of periods, and in the case of this project, it's 2 years, comma, what's the PV is this number, the NPV, comma, what's the FV? 0, close parens. So the answer is $2.38. All right, so let's look at project F. So let's do the same thing. The NPV for project F is $619. Is equal to the rate, which is 10%, comma, the number of periods. In this case, the number of periods is different. It's 4 periods, comma, the PV is the NPV, comma, the future value is 0. So we get a 1.95. In this case, even though the NPV is higher for project F, notice that the equivalent annual annuity is actually not as good. And that's because even project T has less NPV, but you're over in 2 years. Whereas for project F, you have to wait 4 years to get your return. So that's why on an equivalent annual annuity basis, the superior project is actually project T. So that's a way to look at it. It factors in the time period over which you must earn the money under project T versus project F. So now we'll look at another approach, which is called the replacement change, or we repeat the shorter project again so that we can equalize the time difference. So let's look at this, and we have to do a little formatting here. So project T will capture the first two years, copy, put it here. So we see one project of -100, 60, and 60. Then we do it again. We say, okay, let's copy that, and at the end of year 2, let's do it all over again. So at the end of year 2, we'll invest another 100 and get 60 for the 2 years after that. Make a little room here. And so we now have not one project, but projects kind of linked together. So the total cash flows would be as follows. So now instead of having a 2-year project, we now have a 4-year project. 100, 60, net of 40, then 60, 60. Project F is unchanged. It's still a 4-year project. And notice that we now have apples to apples. We have one 4-year project compared to another 4-year project. Now we can pull the NPVs. So let's do project T, and the NPV equals NPV, open parens, discount rate, it's not 0.4, 0.1. So equals NPV, open parens, discount rate, comma, and we go here from T1 to T4, close parens, and we'll factor the $100 investment. So it's 755, and project F is equals NPV, open parens, the rate, comma, and now we go years 1 through 4, close parens, take into account the dollars spent, and it's 619. We've seen that number before above, but to put it side by side. So now it flipped. Where project F, if it was compared to a 2-year project of project T, it would beat it by 619 versus 413. However, if we link together 2 project T's, which has the same time frame as one project F, it flips, and we're better off doing project F. Inherently, what the 2 methods show us is that project T is actually a better project. However, it's just over too quickly. The EAA shows that by saying what's the equivalent annual annuity, and also this idea of replacement chain also shows it, that we're better off with 2 sequences of project F or T rather than one sequence of project F. That is replacement chain.